Okay, on to Chapter 8. We'll be looking at exponential functions and logarithmic functions. First of all, we'll do exponential functions. So we'll do a little bit of review here in section 8.1 of exactly what exponential functions are and what the functions look like. So an exponential function is of the form f of x equals b to the x, where b is a positive constant. So the base b is positive, and the x, the unknown, is in the exponent position. Hence, it's an exponential function. So what we're going to do is we're going to quickly graph four of them. Y equals 2 to the x, 3 to the x, half to the x, and quarter to the x. So let's start with y equals 2 to the x. I'll do it in red. So let's just use like a table of values, but I'm not going to write down the table of values. Just going to say them. So let's use 0. If we put 0 there, 2 to the 0 is 1. If I put 1 in there, 2 to the 1 is 2. How about if I put 2 there? 2 squared is 4. How about if I put 3 there? 2 cubed is 8, and then it's going to be 16. It doesn't fit. Let's also go down to the negatives. If I put negative 1 there, that's a flippin' negative. 2 to the negative 1 is the same as 1 over 2. So when x is negative 1, we're at 1 over 2. When it's negative 2, you flip it again, but then it'd be 2 squared, it'd be 1/4. So at negative 2, it's at a quarter. Negative 3, it's at an eighth. Negative 4, it's at a 16th. And you can see what it's doing. It's getting closer and closer and closer to the x-axis, but it's never actually going to get there. Even at negative 10, it'd be 2 to the negative 10. It's 1 over 2 to the 10th. It's some very, very small amount, but it never actually gets there. So we have an asymptote at the x-axis. So that was this one, the y equals 2x. Now let's pick a new color and let's do this. Y equals 3 to the x. Well, again, if we put 0 in there, 3 to the 0 is 1 again. But if we put 1 in there, 3 to the first is 3. 3 squared is 9. And that's all we can fit. If we put negative 1 in there, it's going to be 1 over 3. So it's going to be a little bit lower than this. Instead of a half, it's going to be a third. Then it's going to go to a ninth. It's just lower. And again, it's very, very hard to draw this. But you're getting closer and closer and closer to the x-axis, but you're never actually reaching it. And excuse my graphs, they're not the best, but hopefully you get a sense there. Okay, let's go on and do this one. Y equals 1/2 to the x. Well, if I raise it to the 0 power, anything to the 0 power is 1. What if I raise it to the first power? Half to the first power is a half. A half to the second power, that's a half squared. Half times a half is a quarter. And then it'd be cubed, it'd be an eighth, and then 16th. So you can see it'd be getting closer and closer to the x-axis here. But what happens over here? Well, if I put negative 1 here, I'd have 1/2 to the negative 1. That's a flippin' negative. This would flip around, just become 2. So at negative 1, it's at 2. At negative 2, it would flip over, flippin' negative, but now it'd be 2 squared, it'd be up at 4. At negative 3, it'd be at 8. At negative 4, it'd be at 16. So it just goes up like this. And hopefully what you recognize is this is very, very similar to the first one we drew. The red one here, isn't it? What's the only difference? There's a reflection over the y-axis. And actually, that's not surprising at all, because y equals 1/2 to the x is exactly the same as 2 to the negative x, right? 2 to the negative x is the same as 1/2 to the x. And if you have a negative in the function like this, transformation tells us that'll be a reflection over the y-axis. So it actually makes sense in terms of transformations too. Okay, last one we'll do, 1/4 to the x. Well, if it's to the 0 power, it's 1. If it's to the first power, it's a quarter, so it's going to be a little bit lower than this. Second power, quarter times a quarter is a 16th. It's really low already, and then it gets lower and lower. If you put negative 1 in here, this would flip. You'd get 4. You're all the way up here already. If you put negative 2 in here, you'd have 4 squared to be 16. So this goes up very fast, and it would end up looking something like this. So now that we've drawn these four, let's make some summaries here. What's the domain of every single one of these all four of these we've drawn? The domain is from negative infinity to infinity, or in other words, all real numbers. Either way you want to write that, negative infinity to infinity, or all real numbers. How about the range? Well, all of them go up to infinity, and how low do they go? They go down to a y value of 0, but do they get there? No, they don't actually get there. There's an asymptote there. So it's going to be 0 with that curved bracket to show non-inclusive up to infinity, or the other way you could say that is y is greater than 0. X-intercept, where's it cross the x-axis? It doesn't. There is no x-intercept in any of these. How about the y-intercept? In every single case, the y-intercept is at 0, 1. It always went through 0, 1. Asymptote. Was there an asymptote? Yes, there is. It's at the x-axis. So you could just put x-axis. What's the equation of the x-axis? It's y equals 0. And the end behavior, remember that is? That's which quadrants it starts and finishes at. So it goes from 1 to 2, or 2 to 1. Doesn't matter which way you write it. I'll write it from 1 to 2, but you could also put 2 to 1. And that's the same, that's consistent for all 4 of the graphs we've drawn here. But of course there is differences. These ones kind of increase, not kind of, they do, they increase from left to right. These decrease from left to right. What's the difference? Has to do with the base. These have a base greater than 1. These have a base between 0 and 1. So let's summarize some information about that on the back. If the base is greater than 1, the function increases for positive values of x, and the increase is more rapid for larger values of b. We saw that when we put a bigger value for b, we put 3 here instead of 2, it went up faster. In terms of limits, what we can say is the limit of b raised to the x power as x approaches negative infinity. So let's look back and see if you can figure this out. So we're talking about this situation where we have a b value greater than 1, and as x approaches negative infinity, so way out here, what are both of these functions getting very, 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 very close to? They're getting very, very, very close to a y value of 0. Okay, what if we look the other way? What's the limit of b to the x power as x approaches infinity? So again, we're just talking about these first two, where the b value is greater than 1. What happens as we head out towards infinity? Well, these are going up with no bound. In other words, they're heading towards infinity. So this equals infinity, this limit. Okay, the other situation we're looking at was when b is between 0 and 1. That's like the fractions we did on the other side. So in that case, the function decreases for positive values of x, and the decrease is more rapid for smaller values of b. So again, we had a smaller value here. This 1/4 is smaller than 1/2, and it's going down faster with the smaller value. So again, we're going to look at two limits. The limit of b raised to the x power as x approaches negative infinity, and the limit of b of x as x approaches infinity. So again, this time we're talking about this situation where your b value is between 0 and 1. Well, as we approach negative infinity, as our x values get really, really, really small, what's happened to the y? It's heading really, really high. It's going up to infinity. And as we head out towards infinity, what happens to the y value? The y value is getting smaller and smaller and smaller and smaller. It's approaching, but never quite reaching 0. So you can see these are reversed depending on the base. Okay, we're going to use this information to answer a question. First of all, you can see that we're going to find the limit when the base is 2. So immediately we know we're only going to be working or concerning ourselves with this information here because our base is 2. And what we want to know is if the exponent's 1 over x minus 3, what does this approach as x approaches 3 from the left-hand side? Okay, well obviously we can't just plug 3 in here because you have 1 over 0. But if we go 3 from the left-hand side, it's almost 3, right? It's 2.999999. And 2.99999 minus 3 is what kind of number? It's a very small negative. So you'd have 1 over a small negative. And 1 divided by a very small negative is equal to negative infinity. So basically what you end up with is this situation right here. You have a base that's greater than 1, in this case it's 2, and your x is approaching negative infinity. So what's your answer going to be close to? It's going to be equal to 0. Okay, just a reminder that the rules of transformations do apply to exponential functions. The function is here, the x, so if something's going to be in the function, it's got to be in the exponential position. In other words, this plus 3 is outside of the function. If you have this plus 3 outside of the function, do you know what that is? What kind of transformation is that? That is a vertical translation 3 steps up. But if it was this one, where it's x plus 3, this is in the function. So this is going to be a horizontal translation. Now, it's going to be a horizontal translation 3 steps to the left. Remember, inside the function, it's kind of the opposite of what you'd expect. Okay, this 3 here, is this in the function or outside the function? That's outside the function. So you know this is going to affect vertically the function. This is a vertical expansion by a factor of 3. This one, I know I'm doing it in a weird order. This 3 here, this multiplier if you want, this is in the function. So this is going to impact it horizontally. This is a horizontal compression by a factor, remember what we say for this? A factor of 1/3. There are a few books I've seen that call this by a factor of 3, but most books, and I prefer this too, since it's a compression, it's a factor of 1/3. Okay, then you got some negatives. One's in the function, one's outside of the function. You know that negatives cause reflections. This reflection is outside the function, so it's going to be a reflection over the x-axis. This one's in the function, so it's going to be a reflection over the y-axis. And there you go. So with that information, you can take the graphs, for example, that we just drew over here, and you could draw your transformations pretty quickly. So if the red one is y equals 2 to the x, and you wanted to draw this one, you take the red one and move it up. This one, you'd move it to the left. This one, you'd reflect it over the x-axis. This one, you'd reflect it over the y-axis. The compressions and expansions are a little bit more difficult, but I'm hoping you get the idea. And you have done that already in Pre-Calculus 12. Okay, everyone, we're all done.